So you told me the sine of 60 degrees is root 3 over 2. Guys, what's the cosine of 60 degrees? Okay, shouldn't we know how to multiply things? When we multiply fractions, we go across. What's root 3 times 1?
Root 3.
What's 2 times 2?
4.
There's your answer, root 3 over 4. So the whole point is so we can actually make calculations based off of these angle measurements. Make sure you know how to do this. All right, next one. Cosine of 5 pi over 6. Notice I said that one first. Times the secant of 5 pi over 6. Doesn't matter what you multiply together first. Which one goes first, which one goes second when you're multiplying two things. No. But, guys, I want you to think about this for a moment. Cosine of 5 pi over 6. Should we know that one off the top of our head pretty quickly? Okay, so let's do this one real quick. Cosine of 5 pi over 6. Is that positive or negative? Negative, because we're in what quadrant? 2, because it's just, this fraction is just under 1, so we're in the second quadrant. What's my reference angle? What is the cosine of 30? So that gives me a negative root 3 over 2. Now, think carefully. Secant of 5 pi over 6. What is it? Are they the same thing? They go together. They're what? Reciprocals. Exactly. So notice, why did I put the cosine of 5 pi over 6 first? Because that's the one I should know, right? But, hey, wait. Secant's just the reciprocal of that if it's the secant of 5 pi over 6. So notice I did the flip and I didn't rationalize. Why didn't I rationalize? Because is that the end answer?
No.
You only need to rationalize at the end. So when I look at this, I'm like, oh, I can multiply this together. A negative 2 times a negative root 3, that's 2 root 3. Denominator, root 3 times 2, that's 2 root 3. Oh, that equals what? That is the reciprocal property of multiplication. If I multiply a number times its reciprocal, it better come out to be numero uno when you're working with it. Don't make things hard. Especially if you're evaluating, don't waste the time rationalizing denominators unless that has a radical in the denominator. All right, here's another one. I think you guys got this down. Make sure we have our operations correctly. We got the cosine of 4 pi over 3 plus the sine of pi over 3. Okay, my friends? Should we be able to find fairly quickly, because we know our unit circle, those values? Who thinks they know the cosine of 4 pi over 3? All right, so a positive or negative? I'm just waiting to see. What do we got? Cosine of 4 pi over 3. What's your reference angle?
60.
What quadrant are we in? We're in the third, so positive or negative? Negative. But what is the cosine of 60? 1/2. Yep. Okay, next one. Sine of pi over 3. Again, what's your reference angle? That makes it really easy. Isn't that 60? What quadrant are you in? First, so we know it's positive. All right, so what's the sine of 60?
Root 3 over 2.
Yep, so that's your root 3 over 2. Now, we have fractions. No big deal. We can easily add fractions if we have a common denominator. Do we have a common denominator? And so what does that become? A negative 1 plus root 3 over... There's nothing to rationalize. You're good. You just leave it that way. You combine it as much as you can. Now, I have a question for you, just a sidebar for a moment. What if I asked you this? Cosine of what gives me root 2 over 2? Now, my question, is that the only possible answer?
No.
But you guys agree with me that I actually agree with Sam, like cosine of 45 is going to be a positive root 2 over 2. Is there any other cosine value that could get 225? 225 to be negative, because that's third quadrant. So which one would it be?
315.
Right on. 4, 3, 15. Now, here's the question. How do I know which one's which? If I don't tell you, both are fair game. Are you guys with me on that? And that's just using the idea of that cosine idea, that if I know root 2 over 2, that's about right here on the x-axis. If I drew it in, you can see it goes into 2 quadrants, right? Oh, over here at 45 and down here at 315. It's very easy to see that. That's just a visual. I like that visual. Your calculator will only ever give you one answer. It will always give you the 45. So, because your calculator is in function mode, and in function mode, for every input, there can only be one what? Output. So if my input is a root 2 over 2, they say 45 is the only thing that can come out. But in reality, could there be 2 answers? Yes. I don't care which one. This is part of homework. This is part of stuff that you can see on your test. So here's like another easy one to do. What if I did the sine of what gives me a negative 1/2? Sine of what gives me a negative 1/2? Right away, what quadrants do you have to be in? 3 or 4. So we know we're in 3 or 4. Great. When is sine equal to 1/2? When we have a 30 reference angle, right? So we know that everything's it's gonna deal with 30. So that either, if you're in degrees, that's either gonna be a 210 or a 330. Are you guys with me on that? So that's either 210 or a 330. I almost think these are easier to do in radians. Because it's like, oh, that's negative. Oh, I know that's a 30, so that's gonna be over 6. I know this is gonna be pi, and then I'm like, oh, it's just over 1, 7 pi over 6, or just under 1, which would be 11 pi over 6, either one of those. So be able to do that with degrees or radians without much of a stretch. Another reason why should you have the unit circle like totally ingrained into that noggin of yours. Correct? I didn't say a new word, noggin, right? Everyone knew what that meant? Like I have some classes with international students. I throw enough new words at them to get noggin as a like their brain. Like I feel horrible. All right. Oh, funny story from yesterday though. I was showing a student what dice was in English, and I'm like, this is a dice. This is how we do probability. And I said, how do you say this in Chinese? And they told me, and I repeated after them. And they're like, you don't need to repeat that after me. I go, why? He said, you just called someone stupid. I'm like, well, there's a reason why. We're just gonna call dice in English then. Like, because I just said the accent wrong perfectly to do stupid. The Chinese students right now think it's very funny. All right. I'll get over it eventually. But it's funny at the time. All right. Here's the thing. Now use what you know about unit circles and what you know about solving for right triangles with trigonometry to come up with answers. We're bringing it all together now. So that's one reason why you want to know your Pythagorean theorem. Now, if you're visual, this is easy. If you're not visual, I don't know what to tell you about become visual on these problems because it makes sense. But the stuff you still need to remember, okay? You still need to remember that the sine of an angle is opposite over what? Hypotenuse. Would you guys agree? And we also know that it's going to be y over the radius or y over the hypotenuse. See where that came from? Okay. Or we know it's y. We also know that cosine theta is going to be adjacent over the hypotenuse, or x over r, because that's the radius of a unit circle, or x. And then we use the idea that cosecant theta and secant theta, aren't those just reciprocals? So I literally could go, yeah, this is hypotenuse over opposite, and this is going to be hypotenuse over adjacent for secant, and it just flip-flops those things, right? We get our 1 over y, our 1 over x. All right, what's the only thing we haven't talked about yet? Tangent and cotangent, right? So tangent theta, we know that's opposite over adjacent. And we know that's also sine over cosine, or aka y over x. All of those are ways of figuring out tangent, which means cotangent's just the reciprocal of all of those. Now, Gregerson, why would I care about this? Because of your next problems. You still are responsible for knowing how to do trigonometry that's not on a unit circle. You still have to be able to look at a right triangle, be able to work with it. But now it's going to get a little more detailed. Here's an example of what I'm talking about. It says the following. The terminal side of an angle in standard position passes through the point 724. Find, and this should say ratios, not ratios of all 6 trig functions. Now, ratios means fractions. Would you guys agree with me on that? So I want you to think about this for a moment. I'm going to redraw it here. Here is going to be my axis, my y and my x axes. It says the terminal side of an angle in standard position. So standard position, I start right here. And it goes to the point 724. Drawing to scale does not matter on this. But it goes through there. Guys, didn't we have a thing called reference triangles that we had to use before? We go up to our point, we draw it straight down, and what type of triangle did we just create there? A right triangle. Doesn't that right triangle have a reference angle? Okay, so when they're saying this, looking for the sine of theta, we have some information. I got 7 and 24. Where's the 7 going to go in my right triangle? The bottom, the horizontal side, right? What is the 24 going to go with? My vertical side. Now, can anyone tell me what my hypotenuse is without calculating? It's our triple. It's a 7, 24, 25 triple. Hypotenuse will always be positive. But if you did not know that, you would have to go like this. 7 squared plus 24 squared equals hypotenuse squared. So 49 plus 576 equals hypotenuse squared. 49 plus 576 is 625. And then when I take the square root of it, you have to keep your plus or minus. That's plus or minus the 25 is equal to hypotenuse. But the cool thing with right triangles in the coordinate plane, your hypotenuse is always positive. The negatives go with your legs. Okay, so they always go with your sine or cosine. So that the case, it's going to be 25. Now guys, look how easy this is to answer. What is the sine of that angle if sine is opposite over hypotenuse? I heard it, 24 over what? 25. Okay, what's the cosine of that angle? 7 over 25. Awesome. What's going to be the tangent of that angle? Yeah, 24 over 7. You see how we're just using the stuff that we used with SOHCAHTOA earlier, now with kind of what we know about unit circle a little bit. Now, I love the last one. We tried to do this on purpose. Guys, the last ones are just reciprocal. So if I know the left side, do I know the right side? Yeah, we just have to do quick flips. So 25 over 24, 25 over 7, 7 over 24. Oh yeah, we have that done. Guys, see how that kind of brings in everything we're doing? Reference angles, reference triangles, right triangles from your geometry days. It's so lovely, so lovely. Okay, reading is also huge on this one. Look at the next one. It says the sine of an angle, so sine of theta, is a negative 24 over 25. And theta is an angle in standard position where terminal side lies in the third quadrant. Okay, so let's make sure we know what we're doing here. Here is my coordinate plane. Initial side, we know terminal side goes where? Somewhere over here. Would you guys agree with me on that? Because it said third quadrant. Oops, guys, gotta make sure I go in the right quadrant. Here we go. Third quadrant. Now, if I'm drawing in my reference triangle, do you agree with me? I go from that point, and we see this lovely right triangle, and my reference angle, I'm still going to call it theta, but really we're using our reference angle. The big angle is actual theta, but we're just using our reference angle for it. Now, what does sine represent? We know it's a negative 24. Why did I put the negative with the 24? What's my ratio for sine? Come on. That's opposite leg over hypotenuse. Okay? Hypotenuse has to be positive. So where is that negative 24 going to have to go? Going down. Think about it. Sine is always going to be in the third quadrant negative. Yes, sir. Question.
Isn't there also a math property where the negative sign always has to be connected to the top of the fraction?
I always do it that way, but it doesn't have to be. makes your life easier most of the time if you do. Because you could also put it just out front. I normally put it in the front, at the top, because it's just easier to keep up with mathematically, but it doesn't necessarily have to go that way. Yes?
Can I go to the
Yes. Now, guys, without a lot of work, can anyone tell me what this side length should be? And be careful. -7, because we went which direction? Do you see now where negatives do matter when we do Pythagorean theorem? So now they matter. So we're going to go here and go -7. Nope, you can keep it. Just don't share it with others. Okay. So now should be based off of this reference angle right here, should we be able to find sine, cosine, tangent, and all the other stuff? All right. So what's cosine theta? Come on. What's cosine? It's going to be what? Yeah, because that's adjacent over hypotenuse. Adjacent's -7, hypotenuse 25. Tangent of theta. What's tangent ratio? Yeah, that's going to be a -24 over a -7, which gives us what? Positive 24/7. Here's the other rule. If it can be reduced, should we reduce our fractions always? Yeah, now that they're reduced, can we just do our quick flips? Yeah, because we're just using our reciprocal function idea now. So this is going to be -25 over 24. Negative can be out front with the 24 or with the 25. Then we have our -25 over 7, and then 7 over 24. Now this is why, because this is based off of the Pythagorean theorem, that you see me keeping plus or minuses with it. Because in trigonometry, can we have a negative now with a side of a triangle? In this context, yes. If I just had a triangle drawn out blue, would I want the negative? No, but on a coordinate plane, negative tells me direction, will help me find my sine and cosine values better. All right, how are we feeling? Are these making sense? Okay, gotta give me something, guys. I know. Yes. Is it making sense? Okay, now let's look at the next one. It says, if tangent theta equals a -8 over 15, and theta is an angle in standard position where terminal side lies in what quadrant? Fourth quadrant. Find the value of the remaining trig functions. So we have right here, we started our angle, and we ended in the fourth quadrant, so we're somewhere over here. If I draw in my reference triangle, that would have been theta. I'm just going to put the theta there where the reference angle goes because it makes my life easier. They say tangent is a -8 over 15. Talk to me. Tangent we know is adjacent over, not adjacent, excuse me, opposite over what? Adjacent, I had to say the right values here. Now, where's the negative going to go? Yeah, with the 8, because it's the one that's going down, the y value. Exactly. And then our adjacent is going to be positive. Can anyone tell me what the hypotenuse is? Right on. It's 8, 15, 17, what? Triple. If not, guess what you would have had to do? You have to do the Pythagorean theorem. If not, you would literally have to go -8 squared. Make sure you always put the parentheses around the negative. 15 squared equals your hypotenuse squared. And you would literally get to this spot where it's what, 289? And you're taking the square root of it, you go plus or minus 17. And then you're like, oh, it's hypotenuse, so it has to be positive. Go back one here. Of course, I got my recording in the way of my value. So let me go back. I don't know if it will. Is this going to let me move? Okay, I just need this to move just a moment. Okay. Is that not letting me go there? No. Nope. Here, hold on. Can we please use my values? There you go. The stuff I'll do to record. Okay. Alright. So, with that, friends, what's your sine of that angle? Sine of the angle? Yeah, -8 over 17. What's your cosine of the angle? 15 over 17 that time. And then can we just do the flips for our reciprocals? Yeah, so this would be a negative 17 over 8. This would be 17 over 15 for secant, and cotangent is going to be negative 15 over 8. Are you guys seeing how these filled up? Do you see why Mrs. Gregerson was really mean? Those of you who had me, this paid off. Those of you who don't have me, this isn't easy for you. Bless you. This is why I push on my students triples, because it saves so much time in calculation. Because I'm going to put these where you're not having to calculate it. And this comes up in advanced pre-cal, regular pre-cal, calculus, all those. Now, let's look at the next one. Guys, how would we go about this one? It says the terminal side of an angle in a standard position passes through the point negative 1160. Find the ratios, make sure I fix that again, the ratios of all 6 trig functions. Okay, now did they give me a quadrant this time? But should I know the quadrant based off of my ordered pair? Yeah, what quadrant am I going to be in? Yeah, because I'm over here on negative 1160. So when I draw in my triangle, because I'm going to draw, because this would be my angle, right? Right here. I'm going to draw in my reference triangle. Here's my theta I'm going to use, because I'm going to use my reference angle to figure this out. If I label this well, the negative 11 goes where? Horizontal or vertical? Horizontal. Where's the 60 go? The vertical. And if we know our triples, we know that's a 61. However, that's not a triple most people know. But let me show you why you want to know that one, okay? Because if we're doing this one and I didn't know that was 61, and those of you who had me as a teacher, I would go like this and go triple with a what? Smiley face, just to prove that I knew my triples yet. But if that's not the case, you guys have to be able to do your Pythagorean theorem, okay? So, leg squared plus leg squared, put the negative in with the parentheses or it will be wrong, equals the hypotenuse squared. So you get 3600 plus 121 equals hypotenuse squared. And that's 3,721 equals hypotenuse squared. You take the square root of it, plus or minus, and you get plus or minus, and this would end up being 61, which no one in their right mind has the square root of 3,721 memorized. Do any of you have that memorized? No, but a triple is a lot easier to memorize. 11, 60, 61. So just know you can get there if you don't know your triples, but you have to know how to use the Pythagorean theorem really, really well. All right, so let's do the trig ratios on this. Guys, what is going to be the sign of the angle? Because we're going to be using this angle. What's the sign going to be? Love it, and it's positive, right? Because our vertical was positive. All right, cosine of the angle. Confidence, good job there, Emery. Negative 11 over 61. What's about the tangent of the angle? Yep. Can I reduce any of those? So can I just use my reciprocal functions to figure out the rest? Which I love. So this is 61 over 60. We get 61 over a negative 11, and we get negative 11 over 60. Guys, what do you think? Does that make sense? Do you see how it uses the idea of different quadrants have different sine and cosine values being positive or negative? So that's how it kind of references your unit circle. What changes though is like we should still know how right triangles are and how to work with a coordinate plane. Also, the other thing that references vertical is always going to help you with your sine value, and horizontal is always going to help you find your cosine value, just like before. So that's what your worksheet is going to be like. So what would a wise person do besides homework? Okay. They're going to do their homework, and they're going to study what? And then you start. Basically, are you supposed to remember everything from geometry now and pre-cal? Yes, that's so loving that we expect you to remember it all.